Alright, going back to a lesson that we already covered in class, but just in case you want to review it, there are two types of probability that we're mainly talking about in this unit, experimental versus theoretical. So, to introduce experimental, we have this problem here. Thomas is supposed to walk the dog when he gets home from school every day. In the last 10 days, he's remembered to do it 4 times and forgotten to do it 6 times. Estimate the probability that he will remember to walk the dog today. Most students found this pretty easy. He remembered 4 times out of 10, so that makes a probability fraction of 4 out of 10. You can turn that into a decimal or a percent or simplify it, but it's a 4 out of 10 probability. So today we're going to talk about experimental and theoretical probability and be able to compare the two. So in the previous class, we started looking at, I have these letters in a bucket, and I draw them out, record what we drew out, and then replace them and keep drawing. Well, I did it 25 times, and my results looked like this first set here. 3 out of the 25 times I got R, 5 out of 25 A, 2 out of 25 I got S, 10 out of 25 I got T, and 5 out of 25 I got I. And we turned these into probability fractions and decimals by dividing. 3 divided by 25 is 12/100ths. Some kids also notice that, 3 times 4 is 12, 5 times 4 is 20, 2 times 4 is 8, 10 times 4 is 40, and so you can do times 4 and get it more quickly than with a calculator. See, 20, 40, 20. Then we added our own draws to the original 25. We got up to 50 draws. I used 8th period's data to be uniform so that everybody would have the same data. So out of 50, and I could count, that's 5, 10, 15, 20, 25, 30, 35, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So it's out of 50. This is 8 out of 50. And I could divide. I could do 8 divided by 50 on my calculator and get 16/100ths. Or I could just say, 50 times 2 is 100, and 8 times 2 is 16, so 16/100ths either way. And here this is also 8/50ths or 16/100ths. And this one is 7/50ths or 14/100ths. And this is 16/50ths or 32/100ths. And then this one is 11/50ths or 22/100ths. And then I asked the students, how did the probability change after more draws? It went from 12 to 16 here, so up 400ths, down 400ths, up 600ths, down 800ths, up 200ths. What we basically end up agreeing on is that it didn't change very much. At most 800ths, which is the same as 8%, which is less than a letter grade. A letter grade is 10 points, 10%. So it's really not that huge of a change. Then we made a guess about the word that was in the bucket, and I told them that it had 6 letters to make it a little bit easier. I asked them, knowing that it has 6 letters and there's only 5 letters here, what do you think happened? How are there 6 letters? And they say, maybe there's more than one. Well, which one would there be more than one of? Probably the T, because we drew the T a lot more. So our letters we determine are R, A, S, T, T, and I. And I tell them that it has something to do with our school, and usually somebody's able to say, artist, that spells artist. and we fill in our probabilities. We got 0.16 here and here, and this one was 0.08. Oh, no, that was the original. Silly me. 0.14, 0.32, and 0.22. And then the theoretical probability, well, the probability of, so theoretical is about possibilities. There's one R in the bucket, and there are 6 letters in the bucket, so that's a 1 out of 6 possibility. There's one A out of 6 letters. There's one S. There's 2 T's out of 6 letters, or 1/3 of them. And there's one I. And of course, if you add these up, 1 plus 1 plus 1 plus 2 plus 1, it makes 6 out of 6. So you got all of the letters covered. And then we do, well, 1 divided by 6 gives us our decimal, 0.16 repeating. So I'm going to go ahead and round that up because 6 means round up. I'm going to round it up to 7. So all of these are the same, 0.17, 0.17, so is this last one. But then I'm going to do 2 divided by 6 and get 0.33 repeating. I would have to let it go because it's 4 below, so I'm going to keep the 3 and let the rest go. So those are my theoretical probabilities, and I ask them which set is closer to theoretical, the one after 50 draws or the one after 25 draws. And we usually agree that the 50 draws a little bit closer. 1600s and 1700s are really close. This is not that far off. This one is really close. The furthest one off is the I. So we agree that after 50 drawings, it's noticeably closer to theoretical. And I ask them, do you think that that's always the case? I mean, we've only done one experiment. How do we know? So, this activity helps to introduce us to the difference between experimental and theoretical probability. When we base probability on data collected from performing trials, this is experimental probability. When we base probability on possible outcomes, this is theoretical probability. Basically, experimental probability is based on what already happened. Theoretical probability is based on, here are the possibilities, so here is what could happen. Both of them make a prediction, but experimental probability uses history, past events. Theoretical uses potential, possibilities, what could happen. And then I asked the kids to work in a little partnership or a small group to use something, a die with a certain number of sides. I have all kinds, 20-sided, 12-sided, 8-sided die, to perform their own experiment, do 10 trials, 25 trials, 50 trials, compare them, find the theoretical probability, just so that they can kind of start to form their own conclusions about, does it always get closer to theoretical the more trials that we perform? And yes, it should, theoretically, but again, it's all probability. So, that's our introduction to theoretical and experimental probability.